Today we'll be talking about angles of rotation and radian measure. Let's begin with some definitions. In trigonometry, an angle of rotation is an angle formed by the starting and ending positions of a ray that rotates about its endpoint. So you might have something like this, and as I rotate that around, let's say counterclockwise, it will end up like so. Well, the angle is how far this traveled. So it's the measure of how far this traveled. And we do this in degrees and radians. Now there's an initial side and a terminal side. The initial side is where we start. Think of like your initials. If your initials are AN, then your first initial is the first letter of your first name, and then your first letter of your last name, so AN. The terminal side is where this ends. So in standard position, the initial side is always the positive x-axis, right here. And I rotate counterclockwise to get a positive angle measure, and I'll end somewhere. Where I end, that's going to be my terminal side. So if I go counterclockwise, this will be a positive angle. And if I go clockwise, then that would be a negative angle. Well, at some point, these two are going to meet up. Let's say I've got this angle here, 257 degrees. I started, my initial side is the positive x-axis, and I kept rotating around until I got right here. That's 257 degrees. Well, I can get to that same spot by moving clockwise negative 103 degrees. This is known as coterminal. These angles are coterminal. The prefix co means to do something kind of together. So think of co-pilots. Co-pilots fly a plane together. Co-workers work together. Here, these angles end at the same spot together. And you can also have an angle that over-rotates. It goes beyond the first rotation, so past 360 degrees, and then if it keeps going, well, it's going to end somewhere. In this case, I went all the way past 360 degrees, and I went another 60 degrees to end up at 420 degrees. Okay, this would be the same as just 60 degrees. Those two are coterminal. So here are some example questions. An angle of 670 degrees is coterminal with what other angle between 0 and 360? Well, I'm starting at 670 degrees. And what I can do is I can add and subtract a full rotation around this circle. So I'm going to subtract 360 degrees. If I do that, 670 minus 360, I end up with 310 degrees, which is between 0 and 360. But more importantly, this is coterminal to 670. An angle of 250 degrees is coterminal with what other angle between 0 and negative 360? So same thing here. I can start with 250, subtract a full rotation. So in this case, it would be 360 degrees. 250 minus 360. This is going to be negative 110 degrees. But what's this about radian measures? Well, radian measure is just another way to measure your angles. We're very used to degrees. 360 degrees is all the way around, so turning all the way around and facing the same way again. In radians, that's 2 pi. If I just go halfway, so if I turn exactly around. That's 180 degrees. Well, in radians, if 360 degrees is all the way around and 2 pi is all the way around in radians, then 180 degrees being halfway around is equal to a single pi in radians. We're going to use this fact, 180 degrees is equal to pi, to help convert from degrees to radians and radians to degrees. If I'm converting from degrees to radians, I'll multiply whatever degree measurement I have by pi over 180. And if I'm trying to go from radians to degrees, I'll take whatever radians I have and multiply that by 180 over pi. So they just flip-flop. Pi over 180, 180 over pi. Why am I allowed to do this? Well, that's because 180 degrees is equal to pi. If those two are equal to each other, then pi over 180 or 180 over pi is really just a special 1. I'm multiplying by a special 1. And that changes the way that this looks, but it doesn't really change anything about that measurement. So it doesn't change it getting bigger or smaller. It will stay the same. So let's do some of these conversions. Let's go from degrees to radians first. Let's start with 20 degrees. I'm going to multiply this by pi over 180, as it states here. In fact, I'm going to do that to all of these. So I'm just going to go ahead, 315 degrees times pi over 180 degrees. 600 degrees times pi over 180 degrees. Negative 60 degrees times pi over 180 degrees. Well, just multiply to the top here. So this will be 20 pi over 180. This will be 315 pi over 180. This is 600 pi over 180. And this is negative 60 pi over 180. Now what I'll want to do is reduce these. So 20 over 180. 20 over 180, let's see. They're both divisible by 2, so that would be 10 over 90. And then I can divide by 2 again to get 5 over 45. And then 5 and 45 are both divisible by 5, so that'd be 1 over 9. So this would be pi over 9. Now, if you have access to a calculator, there's a little trick. You can do 20 divided by 180, ignoring the pi here, and you'll get this decimal, 0.1 repeating. To change this to a fraction in your calculator, just hit Math, enter for fraction, and then hit enter again, and you'll get 1 over 9. So this would be 1 pi over 9, or just pi over 9. We're going to do that for the rest of these. So 315 divided by 180. So I ignore the pi, and I get 1.75. Math, enter, enter. This is 7 over 4. So this is going to be 7 pi over 4. For 600 pi over 180, ignore the pi, so 600 divided by 180. This is 3.3 repeating. Math, enter, enter. 10 over 3, so this will be 10 pi over 3. Lastly, negative 60 divided by 180. Math, enter, enter. Negative 1/3, so we'll do negative pi over 3. Now let's do radians to degrees. For radians to degrees, instead of pi over 180, I'll be multiplying by 180 over pi. So let's do that to all of these. So for every single one of these, I'm going to multiply by 180 degrees over pi. Now what you'll notice is when I go straight across, I'll get 180 pi over 8 pi. I've got pi on the top and the bottom. So this means they'll divide out. And that's going to happen to each of these. 4 pi times 180, 4 times 180 is 720. So this will be 720 pi over 3 pi. And pi's will divide out. 9 times 180 is 1,620 pi over 2 pi. And pi's will divide out. And negative 7 times 180 is negative 1,260 pi over 12 pi. And pi's will divide out. The last thing to do is in your calculator, 180 divided by 8, this will be 22.5 degrees. 720 divided by 3, this is 240 degrees. 1,620 divided by 2 is 810 degrees. And negative 1,260 divided by 12, this will be negative 105 degrees. Let's also talk about arc lengths. For a circle of radius r, arc length s, and central angle theta, s equals r times theta. Note, the central angle used should be in radians. So I'm going to try and draw a little picture here. Let's draw a circle, or at least the best attempt we can at a circle. All right, let's see. Yeah, that's okay. That'll have to do. So I've got a radius. So from the center to over here, let's call that r. And let's say I'm going to rotate that by this much. Well, the angle here is going to be theta, and the arc length is the part of the circle on the outside here that's just from my initial side, where that ends, to my terminal or ending. So this is S. So the circumference, if you recall, is all the way around a circle. The arc length is just part of that. Here's a problem. Assuming that the Earth is a sphere of radius 4,000 miles, Find the distance between Cincinnati, Ohio and Huntsville, Alabama, given their central angle is 4.62 degrees. All right, so I've got a note. It said central angle should be in radians. So I'm going to have to first convert this. 4.62 degrees. I now know to convert to radians, I multiply by pi over 180. So this will be 4.62 pi over 180. Let's reduce this. 4.62 divided by 180. Math, enter, enter. This will be 77 over 3,000. I'll say 77 pi over 3,000. Now, to use the arc length formula. The arc length formula is S equals R theta. R, in this case, is going to be 4,000 miles. Times theta, this is 77 pi over 3,000. So S is equal to, you can just go ahead and put that in the calculator, 4,000 times 77 pi divided by 3,000 is 322.5 miles. It is roughly 322.5 miles from Cincinnati, Ohio to Huntsville, Alabama. The last thing you'll need are how to find positive and negative coterminal angles for something in degrees as well as for something in radians. Degrees is going to be a little more familiar. For something that's positive, we're just going to add 360 degrees. So 9 degrees plus 360 degrees, well, that's going to be 369 degrees. For something that's negative, we'll do 9 degrees minus a full rotation, 360 degrees. And that'll be negative 351 degrees. In radians, though, this is going to be 3 pi over 5 plus 2 pi, because that's a full rotation in radians. For something that's negative, we'll do 3 pi over 5 minus 2 pi. The problem here is I can't just add or subtract 2 pi, at least not the way that it is now, because 3 pi over 5 has a denominator of 5. So what I can do is over here, I can say 2 pi is the same as 2 pi over 1. And I need a common denominator. So I'm going to multiply the top and the bottom by the denominator that I've got over here. So I'm going to multiply by 5 over 5. This is going to be 10 pi over 5. So instead of adding 2 pi or subtracting 2 pi, I'll be adding and subtracting it as 10 pi over 5. Now I can go ahead and add or subtract. 3 plus 10 is 13, so this will be 13 pi over 5. And 3 minus 10 is going to be negative 7. So this will be negative 7 pi over 5. Something to note, if what you start with is already greater than 1 full rotation, so in degrees, that would be something that's greater than 360 degrees. In radians, that's going to be something that's greater than 2 pi. Then you can also subtract one full rotation. So that's either subtracting 360 degrees or subtracting 2 pi, and you'll still end up with something that's a positive coterminal angle. Positive just means greater than 0. So as long as your answer is greater than 0, it'll be positive. Negative, of course, means less than 0. So if you start with something greater than one full rotation, you can subtract that rotation, find something that's positive, and then keep subtracting until you end up with something negative. Hope this helps. If you have questions, let me know.